Hello, this is the first part of the video lecture series on solving triangles. So in this video series, we'll be looking at um, different types of triangle. Then we look at Pythagoras theorem, Pythagoras, or what is Pythagorean, same theorem. Then we look at trigonometric ratios of acute angles, acute angles are angles less than 90 degrees. Then we look at angle of elevation and depression. Elevation and depression. Then we look at sine and cosine rule and its application. Then we look at bearing and distances. Bearing and distances. So this will be a series of videos. So in this first part, we will look at probably types of triangle and Pythagoras theorem. So let's get started. Now, types of triangle. I'm sure you know the different types of triangles that we have. This will just be a revision. So the first type I'll talk about is the equilateral triangle. Equilateral triangle. So for equilateral triangles, we have all sides and angles are equal. So how do you identify that? So we see a triangle that looks like that with all the sides the same. That's how you indicate that. You see, when you see these lines drawn across the sides for all the sides, then it means that they are equal. And by implication, all the angles too must be equal. If all the sides are equal, all the angles must be equal. And because you know that the sum of angles in a triangle must add up to 180 degrees, then it means that each of these angles must be 60 degrees. So we're not solving angles, but I just like to put that. Then the second type of triangle is isosceles triangle. So for isosceles triangle, we have the base angles and two sides are equal. So you have, how do you identify that? You have something like that, and you have these two sides equal. So, and by implication, if these two sides are equal, these two angles, which are the base angles, the angles that is resting on the base of the triangle, they must be the same. So if this is x, this has to be x as well. Degrees. So that's isosceles. Two sides are equal, and by implication, the base angles will be equal. Then the next type of triangle will be we look at equilateral, isosceles, right angle triangle. Right angled triangle. So this will be the main focus of the second part of the video of this lecture. Right angle triangle. You have one of the angles is a right angle. So what do I mean by right angle? 90 degrees. So how do we identify it? see it that way. So like that, and you have a right angle here. So anytime you see this triangle, then you know it is a right angle triangle. So I don't even need to put a 90 degree, because once you see this angle here, it means the angle is 90. So, and when you have a right angle triangle, the side that is facing the right angle is known as hypotenuse. The side, depending on where you have the angle, but this, let's assume I have an angle here, this will be opposite, and the other one will be adjacent. Okay. So we also have another type of triangle, scaling. So for scaling triangle, none of the sides or angles are equal. So for scaling triangle, you have something that looks like this, like that, and see, this is not equal to this, and is not equal to this. So we have different number of lines there. So it shows that none of the sides are equal. So those are the main types of triangle. But the focus of the second part of this video will be on the right angle triangle. So now let's look at the right angle triangle. Right angled. Should be right angled triangle. So when you have a right angle triangle, you can apply Pythagoras theorem, or you can also apply the trigonometric ratios. So, but in this first part, we look at the Pythagoras theorem. So what do I mean by that? So if you have a right angle triangle, so the relationship between the three sides is given by the Pythagoras theorem. So if, let's say you have this triangle labeled as ABC, BC, example. So this side will be C, the side facing the angle C will be small c, the side facing angle B will be small b, and the side facing angle A will be small a. So what Pythagoras theorem states is that the square of the hypotenuse is always the side facing the right angle, and is usually the longest. It's always the longest side. So the square of the longest side, which is the hypotenuse, will be equal to the sum of squares of the other two sides. A squared plus b squared. So, which means if you have two of these sides, you can calculate the third one. So you apply this theorem when you are looking for one side and you have the other two sides, provided you have a triangle that has a right angle. So you only apply it when you have a right angle triangle. Then now, the combination of numbers that obey the right angle triangle is known as a Pythagoras, that obey the Pythagoras theorem, is known as the Pythagoras triple. So what do we mean by Pythagoras triple? So let's look at Pythagoras triple. So by Pythagoras triple, I mean that when you have three numbers, if it follows that the square of one of the numbers is equal to the sum of squares of the other two, then you have Pythagoras triple. For example, if you have 5, 4, and 3, they form Pythagoras triple. Why? Because the square of 5 will be equal to the sum of squares of 4 and 3. So because if you square this, that gives you 25. And if you square this, that gives you 16, and these will give you 9. We add this together, then 25 equals 25. It shows that 5, 4, and 3 are Pythagoras triple. 5, 4, and 3. When we asked to find some Pythagoras triple, maybe you know two numbers. What is the third number such that the combination of numbers will form the Pythagoras triple? So you just apply the Pythagoras theorem. But there is a simple way of generating there's a trick for generating Pythagoras triples. Let's say you want to find like a lot of Pythagoras triple without wasting much of your time. There's a way you can do that. So this rule will always work. So if you have two numbers, let's say you have two numbers, S and T, given two numbers S and T, the set below is a set of Pythagoras triples. Set of Pythagoras triples that could be formed. So how do I get that? So 2st s squared minus t squared and s squared plus t squared. What do I mean? If I pick any integer for s and t, then I can form Pythagoras triple from it. So let's take some example. For example, if I take s as 2 and I take t as 1, I can generate Pythagoras triple from this. But you have to make sure that s is greater than t. So take note of that. Pick a number such that s is greater than t. So if I substitute these numbers, s equals 2 and t equals 1 here, then I will generate a Pythagoras triple. So let's see. So now I will have 2 times 2 times 1, then 2 squared minus 1 squared, and 2 squared plus 1 squared. So if I solve this, I will have 2 times 2, 4, 4 times 1, that's 4. So this will give me 4 minus 1. 2 squared will give me 4 minus 1 squared is 1, that will give you 3. And this will give you a 4 plus 1, that's 5. So that's exactly the example I use here. So 5 squared will be equal to 4 squared plus 3 squared. So let's take another example. This is just a random number, not a random set of numbers like s equals 2, t equals 1. I can take any number. So let's pick another values for s and t. So let's say I pick s equals 3 and t equals 2. I can also generate Pythagoras triple from that. So if I use my rule, 2st s squared minus t squared and s squared plus t squared, then I can form Pythagoras triple from this. So now I'll have 2 times 3 times 2, because s is 3 and t is 2, then 3 squared minus 2 squared, and 3 squared plus 2 squared. So this will give me 2 times 3, 6 times 2, 12, and this will give me 3 squared will be 9 minus 2 squared will be 4, 9 minus 4 is 5, and 3 squared is 9, 9 plus 4 will be 13. So you can see this is definitely Pythagoras triple because the square of 13 will be equal to the sum of square of 12 and 5. So 169 equals 144 plus 25. So you can see clearly that 169 equals 169. So that's the set of Pythagoras triple that could be formed. So we stop there in this first part of the video, and in the next video, so we continue from application of Pythagoras theorem. So see you then.